Here I'm going to show how to do the cam for these 1/8 inch thick gusset plates. I have 4 of them and I've placed them on the large 18 by 36 fixture plate that is on the large mill. And I've spaced them out pretty generously. You could probably get them a little bit closer. Once you've got the assembly created and the 1/8 inch plates resting on the fixture plate like that, and spread out, you can go and start with the setup. First thing on the setup, I'm just going to go to selected point, choose the back corner as the origin of the work coordinate system. Then I want to tell Inventor what the model or models are. And so I'm selecting the 4 gussets so Inventor knows that that is what I'm trying to machine. And then I'm actually going to click here and click the plate to tell Inventor that that is the actual fixture, and I'm not going to be machining that. On the stock, I think that the easiest way to do that is just do a relative size box, maybe with a side offset of 1 inch. That's kind of the lazy way to do it. You could design a piece of stock as a part, place it in there, and then choose from solid. So that's another way to do that. Just make sure that the thickness of the stock is the same as the thickness of the material. And so there's no top offset. Once we have this, I can hit OK. I'm going to call this setup 1 here. And the first thing we want to do is the boring operation where we bore some holes to put some socket button head screws in to hold the stock material to the fixture plate. Then we have another operation where we, or another setup I should say, where we actually do the machining of the parts. So looking around, I'll probably put a few boring holes here, maybe one here, here, and here, and then along this edge as well. So I'll put in 9 or 10 should be sufficient. Remember, we're not going to drill into the plate. We're going to do a boring operation. And so here we'll select bore, if I could find it, bore. And the tool that we're going to use is from the large tool library, the large mill tool library, and it's this 3/16 end mill. And then what I'm going to do is select certain points. So I'm going to select my geometry. And you want to make sure you select the circular reference, not just the top of the circular hole. Again, we don't need a ton of holes, but we need enough to hold the plate flat. And so I think that will be sufficient there. And now we need the depths. We definitely don't want to be boring to the bottom of that hole. So this is a little bit different. We're going to go, the bottom height is going to, I'm just going to go selection, and I'm going to select this fixture plate, and I want to be off of that by at least 3/1000 of an inch. Okay, so the bottom isn't into the fixture plate, it is just above the fixture plate. And so that's this. The top height, we actually need the top to be like the model top, and we can go a little bit over that if we need. And then the retract height is above the stock. And sometimes we need to go a little bit higher than this if there are clamps holding down this plate. And so sometimes a retract height can be even like 2 inches or something. For now, we'll keep it like that. Before we're done, we need to set the diameter of the holes that we're going to bore. And to do that, we're going to go here under linking parameters. Oh, not linking parameters. I think it's here under, I'm sorry, here under passes, under stock to leave. We're going to have a negative stock to leave. And we found if you do about a negative 40,000 stock to leave, that makes a hole just the right size for the 1/4 inch button head screws to fit through. One thing I don't like is how big or how steep this helix is. And so if you go define ramp angle instead of pitch, it chooses 2 degrees, which we found to be pretty nice. And so that should be sufficient. And so we can go OK. And we just want to make sure that our bores, the bottom of them are not touching the fixture plate. And again, look here, we're above the fixture plate by that 3/1000 of an inch. And so now that we have that done, we're done with the first setup. Now to save a little bit of time, I just duplicate this setup and delete the boring operation here. And we're all set up for setup 2, which is the actual machining. Now I know in other videos, I've actually created an assembly where I placed the button head cap screws in these holes to ensure that the end mill didn't hit those. But since I provided such a generous amount of space, there's no way that a 1/4 inch end mill going around the perimeter will hit any of these screw heads. So the first thing that I think we'll do is do all of the holes. Again, we're not going to be drilling. We're going to be boring, and these holes are 0.196 inches in diameter. So we need a really small end mill. We'll use the 1/8 inch end mill, and we'll go bore. And we're going to select these circular faces here. You can select the same diameter, and that should be able to select all of them. Now, what we want to use is a smaller end mill. We'll use the 1/8 inch end mill. Again, the depth is not the bottom of this hole. We want to be above that. Yes, it is the bottom of the hole in the plate, so that's fine, but we want to be above that by about 3/1000 of an inch. Anything less is getting a little too close to the fixture plate. Anything more is a little bit harder to clear out. The other thing that we need to do, again, is define ramp angle instead of pitch. We'll keep it at 2 degrees. And we don't want any extra stock to leave there. So that should work there, that we're now boring all the holes. Sometimes what I like to do is our hole top, sometimes I like to be just a little bit above that. So we start the helix before we enter into the plate. If you don't do that, you should be all right, but it's just a little bit of a safety factor there. And I think that's about it on there. So now the holes are done. The next thing we want to do is clear out these little triangles, the weight reduction there, with a 2D adaptive clearing. And so we need to find the 2D adaptive clearing. I'm going to select these pockets here. Notice I'm selecting the bottom edge. We'll change the end mill to something larger. We'll go to the 1/4 inch stub end mill. It's kind of our go-to tool. The depth, again, we're going to be 3/1000 above, not 30/1000, but 3/1000 above the bottom. We do not want any axial stock to leave. 10/1000 on the radial is fine. You can select smoothing. And that should be about it. I don't think there's anything that we need to do here. Click OK. That should clear that out. We can right click and create derived operation, 2D milling contour. And that chooses the same tool, the same geometry, the same depth, and it just clears out the material. Notice there's no stock to leave there, and we hit OK. And so that contour cleans out the edge, makes a nice edge there. Notice that the default lead-in is fine. We're coming in with a nice lead-in. There should be no material there as it comes in, goes around it, and exits. So the final thing is to cut around the perimeter. And so that is going to be done with a contour. And so we're going to do a 2D contour. If I can find that. 2D contour. And we're going to go around each of these. So our geometry is here. It looks like I missed the first one. I typically just choose the bottom of the plate there. And we'll use the same tool, tool number 4. Since this is a slot cut, let's reduce the cutting feed rate to half the default speed. Our depth, we want to be above the fixture plate by 3 thousandths. We want to do some smoothing here. We don't need to repeat a finishing pass, but we do want multiple depths. You could probably get by with a single depth since we're doing 1/8 inch. Definitely if we're doing 1/4 inch, we want multiple depths. But just to be safe, let's go just something a little over half the thickness of the part. So our maximum roughing stuff down, if this is 1/8 of an inch, I'll go just over the 1/16. And then what I finally like to do is we want to change the lead-in sweep angle to 0, and we want to ramp into the material. Now, when I hit OK, you can take a look. There's a couple things just to be aware of. One, I'm getting a little warning. There's a little check mark. And one thing I forgot to do, and that was to add tabs. The tabs will help hold the piece in place. There's a good chance it won't fly out because we're leaving that 3 thousandths, but that's a little bit, you're gambling that there's the part may flip out and chip the end mill. So let's first right click and go into the show log, and it will tell you it dropped one of the linking constraints. Okay, and that's the log message. It still created the path, but for some reason it dropped a linking constraint. And it appears it's on the exit there. I am not positive. It will still run with that error, but we can maybe take a look at some of the linking constraints here. It might be the angle, and it might be the lead out. I am not positive. That's something we could play around with, but at this point, I don't want to take the time, but we could play around with that. I'll take a look at it later and see if I can find it so I'm not taking time up on the video. The one last thing though is we do want to put some tabs. I like the triangular tabs. A 1/16 of an inch is pretty thick. Maybe we'll go 25 thousandths tabs, and we can play around that. We notice these have 3 tabs. Maybe we want more so we can decrease the distance between them. I'll go still at 1.5. It just has 3, maybe 1.25. Will give us maybe 1.2. That looks pretty good. You can see that we now have 6 tabs here. If you want to play around with the width of the tab, that's all right. But I think that's going to help hold the piece in place, and then we can cut that out at the end. And so there we go. So now we can do a simulate on the actual cutout. And we get the boring. I'll skip through that. Then we have the adaptive clearing. Once that's done, we do the contour, clear out all of those. And then the final is the actual ramp down as it cuts out the perimeter. One thing I skipped over and didn't explain why is why I prefer to, or why I have you change on the linking parameter, the sweep in angle. We do not want to lead in perpendicular like this and go around, because what happens is when you lead out, if you lead out this way, you're going to be cutting through the full thickness of the material, and there's a chance you'll break the end mill as you're just doing the slot cut on the way out. And so that's why I prefer to do that. You could have a lead in at 90 degrees, but then just make sure your lead out does not have that in there. Okay, that's it.